reducing to quadratics, or it's called hidden quadratics. That means you're not necessarily going to see that it is a quadratic from the outset. It's going to look like something else, but you will be able to see a quadratic in it. So as you can see, we're solving. So we want to solve, right? Now, when you look at this, you are not dealing with, when you look at it, you would realize that you're not really dealing with quadratics when you look at it, because quadratic is when the highest power is raised to a 2, and you're seeing something to a 4 here. Take this and to do something with it so that you turn everything into a quadratic. So if you observe this, we are able to say, let x squared equal to something. So let us say we say let x squared equal to k. We can let it be anything. All right, so we're going to let x squared equal to k such that 2k squared, because remember I know x squared is equal to k. So you could see how I would have k squared here, because remember x squared is k. So if I have k squared, that means this is squared and become 4. So technically you're seeing where we're compensating for that 4 right there. So that becomes a k squared with a 7 with just k alone, because x squared is k, plus 3 equals 0. Take a look at it. Let us observe how we had moved on from here to there, using this as our guiding tool right there. So at the end of the day now, we're going to find values for k, but that's not going to be the answer, because we are hiding something to come back to it. So you could see here that we now reduce. This was actually reduced to a quadratic. So you're seeing that it was reduced to a quadratic right there. Then from this, I would say to you, solve your quadratic normally. In this case, your A is 2, your B is -7, and your C is 3. AC will be 2 times 3, and that is 6. The factor pairs, 1 times 6, 2 times 3. Which one of this can give us 7? 1 and the 6. So you're looking at the fact that you're employing your regular factor, your regular solving of a quadratic right now. So you're back at what you were doing just now, only that you're dealing with a different case, but you're still using your regular skills from the last topic. So now we'll have 2k squared. This is going to be a negative k, or 1k if you want to say 1k, you know, and then a minus 6k, and then this is a positive 3, and this is equal to 0. So you could see here that we use these numbers here to help us to get back the idea. Remember, when your AC is positive, it's either you have 2 positive or 2 negative. But when you look at B, let the sign for B help you. So because B was a negative, it means that we're going to have a -1 and a -6. If you multiply them, you get back +6. And if you add them, you get back -7, which is exactly what you wanted. So at this stage, we're going to have to now factorize this and factorize that. What are we going to take out here? K. K into 2k squared, we're left with 2k. And k into -1k, we're left with -1. What are we going to have to take out here? We would have to take out -3, such that -3 into the -6 would give us +2k. Why am I making sure? The brackets must come back to be the exact identical twins. So I have to manipulate what sign I use there so that I get the result that I want. Then this becomes -1, and this is equal to 0. Now, at this time, we have 2k -1, and then we have k -3, and this is equal to 0. So 2k minus 1 and then k minus 3, and this is equal to 0. Now, you're at this stage where you can say either 2k minus 1 is a 0, or k minus 3 is a 0. Now, at this time, we're saying 2k is equal to 1, which means k is a half, or k is equal to 3. Now, we're not finished because k was not in the original math. So we have now found two values for k that are good to go, but the question is not yet finished. Now, at this time, what we're going to do now is to go back to the beginning, right? So we want to go to the beginning and say, all right, remember though, that in the beginning, that we were the ones that said, let x squared equal k. So I'll say, recall this, recall that x squared is equal to k. We want to remember. We want to remember this. Because remember, we're solving for x. So at this time now, we are going to say, oh, we recall that k is equal to x squared. Therefore, we can rewrite this by saying x squared is equal to a half. All right? Or x squared is equal to 3. Remember that we are utilizing back that fact that we started right there. Now it is that we can go to the real answer. Remember that when you drop a square root over a number, we're going to have plus or minus of that. And then x is going to be the plus or minus of that. Square root of a half, or positive or minus square root of 3. There it is. So that's just one example. I will go through more. So we'll start this by I'm going to let a square equal to anything. I'm going to use k again, which means that from the beginning here, I'll have k square, because this is to the 4th power is square square. So that will sort out that part. Minus 10 with just k now. And then I'm going to migrate this negative 21. It's going to be positive 21 on the other side. So it's positive 21, and this is now equal to 0. As you can see, we have a quadratic here. So in solving my quadratic, what I'm going to do is I need to write down what is my a, which is 1, my b, which is negative 10, and my c, which is 21. AC really means a times c, which is 1 times 21, which is 21. What are the two numbers for 21 that can give a 10? And it's going to be 3 and 7. They both will be negative again. Why? Because I need to get back a negative 10 by adding and a positive 21 by multiplying. So therefore, we'll have k squared minus 3k minus 7k. And then this is positive 21, and this is equal to 0. As you can see here, we could factorize that part and then factorize this. What's my factor for the first piece? K, open bracket. K into k squared, I'll be left with k, and then a minus 3, then a minus 7, and then I'll end up with a k and a minus 3 again. And this is equal to 0. From here, k minus 3 times k minus 7 is equal to 0. At this time, remember, I need to solve for k. So either k minus 3 would give us 0. If not, k minus 7 is equal to a 0. From here, k is equal to 3, and k is equal to 7. Now, remember that originally there was no k in the situation. We had a. We were the ones that said let a squared equal to k. Now at this time, I'm going to substitute back my k for my a squared for k. So I could now say a squared is equal to 3, or I have a squared is equal to 7. Let's find the values. We take the square root. But remember that when we take the square root of a number, it's going to be a plus or a minus root 3. And then for this, a is going to be a plus or a minus of root 7. These are our answers. We have those, we have those.